Alrighty, so today we're going to go ahead and talk about translations. Woo! Maybe. Okay, so just a couple terminologies that we've talked about, but now we're really going to go, I've mentioned them, but we didn't have them on our vocab. We're really going to talk about them today. A transformation of a geometric figure is a change in its position, shape, or size. So we've done some transformations. We did some dilations. So we've done a little bit. We've talked about the pre-image and the image. How the pre-image is what we see first and the image is what we see after. And then we've also talked about an isometry, and that is when they are the same. Things that stay the same no matter what I do to it. So if I pick you up and move you around, you are still you. You're just in a different spot. Remember, dilations are not isometries because they're not the same size. We made them bigger or smaller. Okay, so this is what we're going to end up doing in the next coming days. We're going to do translations, which we're going to slide things around, so I'm going to just move it around. Reflections, which means here's my thing, and I'm going to flip it. I'm going to flip it. Rotations, which we kind of already have seen a little bit, but now we're going to mathematically do them. So we're going to flip stuff. And then we're going to do a combination of glide reflections, which is when we slide and then flip it. Slide it and flip it. So first we're going to talk about isometries. So what is an isometry? Excuse me, are these isometries? Why or why not? And my explanations are not good on me doing with my fingers, so I'm going to type these out. So these first two, what do you notice about my pre-image to my image? An isometry is the same shape that stays the same size. So on this one, it is not an isometry. And it doesn't, my computer doesn't like the word isometry, but it does exist. It just does not like math terminology. Because it is not the same size. Alrighty, the second one. Isometry or not? Good. Everything stayed the same. I just flipped it. Remember, if I'm going too fast, just go ahead and pause these videos. Pause it for a second, turn it back on. Don't feel like you need to keep up with me. Extend this a little bit so that way you guys can see that better. I can write, alright, pre-image to image. Same, not the same. Good, same, so that's an isometry. Same idea. I just flipped it. And what about these last two? Isometry or not an isometry? Good, not an isometry. It's flipped and bigger. Alright, so when I'm talking about a transformation map, it's talking about how I'm changing my shape. So it can be described with an arrow, like what I see here. And it can also be described with the prime stuff, which we've also already talked about. So K goes to K prime, J goes to J prime. Come on. J goes to J prime. And Q goes to Q prime. So just talking about the equal pieces all lining up together. So let's go ahead and talk about that translation today. That translation or a slide is, again, an isometry that maps everything the same distance and same direction. The diagram below shows a translation of the square 8 units right and 4 units down. So that means that what I did to each of my x and y points is 8 to the right. Think about it. I have to go backwards, sorry. 8 to the right means I'm going to go positive. 4 down means I'm going negative. So I'm going to add to my x and subtract to my y. So I took my original points. Here they are in red. I added 8 to every exponent, or every x component. Whew. I added 8 to every x component, and I subtracted 4 to every y component. So my new shape is down here in the blue. So let's do one together. So we are going to translate this image 2 to the left. Hold on. 2 to the left and 5 down. So we're going to take our x values and we're going to subtract 2. So I have negative 3 minus 2, which will put me at negative 5. And then I have that 4 minus 5, which gives me negative 1. So x prime is going to be at negative 5, negative 1. Y prime will be at 5 minus 2, which is 3. 4 minus 5, which is at negative 1. We have 2 minus 2, which gives me 0. And 1 minus 5, which gives me negative 4. So these are going to be my new coordinates. So I have negative 5, negative 1. I have 3, negative 1. And I have 0, negative 4. So my shape should look the same. Granted, again, drawing on my computer is not the easiest. Paper should look a little bit closer. But we end up essentially with the same shape, just slid it to the left and down a little bit. Okay, now we're going to subtract 6 from our x's and add 2 to our y's. So 3 minus 6 puts my e prime at negative 3. 1 plus 2 puts me at positive 3. My f prime will be at 7 minus 6, which is 1. And negative 1 plus 2, which is positive 1. Then I have 4 minus 6, which gives me negative 2. And then I have negative 4 plus 2, which is a negative 2. So some pretty nice points that I'm getting here. So e prime will be at negative 3, positive 3. F will be at 1, 1. Oh, come on. And G will be at negative 2. Hey, this apparently is not a negative. I'm going to cut that bad boy out. He's actually positive, which is why he's up here. So, can I get in there? Nope, apparently not. So he's actually positive, which means this is positive, which means this is actually... Wondered why. I'm like, why is this going down? That doesn't make sense. Actually a 6. So I'm at negative 2, positive 6. It's not even notice that had happened at all. I'll have to fix that for next time. Sorry about that, guys. So now my red shape is just slid over to my blue shape. I want you to try this one on your own. I'm going to do a little bit, and then you can make sure. I want you to pause it, obviously, and then come back and check it. Just pause video, do this one, come back, check your answer. Alright, your red triangle should, or excuse me, your blue triangle should look like my blue triangle. Okay, so sometimes we're asked to describe the translation, so we're trying to figure out how did my shape change? Where did it go? So if my P is originally at 3 and goes down to -3, it means that the red one has to be my original. So the red one is going to be my pre-image. And my blue one is my image. So logically we know it went, logically we know it went to the left and up. So if I go to the left, it means I'm subtracting. So if we take that first one for the example, 3 minus something gave me -3. So let's figure out what that is. minus 3, negative x equals -6. So x is 6. That means I subtracted 6. So I took my x terms and I subtracted 6. I went to the left 6. Or, if you wanted to, here's my p up here. Here's my p prime. Stop. Computer wants to be dumb. Here's my 3, right? 1, 2, 3, 4, 5, 6. Why are you centered still there? For some reason, it's still picking up my finger marks. Hold on. 1, 2, 3, 4, 5, 6. So I went 6 to the left to get from P to P prime on my x's. So let's take a look at my y's now. I was originally up at 4, but now I'm up even more at 7. So I took my y's and I added 3. So I went up 1, 2, 3. Okay, that's all I have for you. Go do your homework.